Hello, my friends. I'm Clover, and this is the gas puzzle that was originally posted on Friday, September 6th, 2024 by Philip Newman. This is a region sum line Sudoku. So we have normal Sudoku rules, so we're placing the digits 1 through 9 once each in each row, each column, and each outlined 3x3 region. And then on top of that, we have region sum lines. So we have these blue lines in the grid, and each of these lines goes through at least 2 different regions. And the rule says that in each of the regions it passes through, the sum of the digits on the line in that region has to be equal. So what that means on this line, for example, is that this digit, because it's just one digit, so it's just kind of the sum of itself, it's just a sum of one digit, is equal to the sum of these 3 digits, and it is also equal to this digit. In other words, orange and orange are the same, and they are the same as the sum of those 3 numbers. Or, for example, orange here is the same as the sum of green. And the first thing that stands out to me in this puzzle is that we have this kind of central construction where each of these digits has to be able to be formed as the sum of 3 other numbers that are valid in a Sudoku grid. You can't do that with the digit 5, so 5 can't go on any of these cells. So 5 is going to go there, and then these will be 6, 7, 8, and 9. So I'm going to start up at the top here. Whatever this number is has to be the sum of these 3 numbers, and those 3 numbers by Sudoku rules can't include a 1 at all. And so the only way for that to work is for that to be 9, and for these to be minimal, they would be 2, 3, and 4. 3 can't go in those cells, 4 can't go in that cell, so that is taken care of, and then we also know that this is a repeated 9. So then we're going to work our way around, and this is going to work out really neatly. This cell, 6 can only be formed as 1, 2, 3, 7 can only be formed as 1, 2, 4. Those both include a 2, so this actually has to be an 8, and the 8 has to be the sum of 1, 3, and 4. The 4s can't go in the top 2 cells, so it goes there. 1 can't go there, and that's taken care of, and then 8 is going to repeat here. We're going to get very similar logic here. 6 is 1, 2, 3 always if they all see each other, so that can't be 6 because there's a 3 in the region. That's a 7. That makes this 1, 2, 4. 1 can't go in these cells, so that is a 1. That's going to be a 4, and that will be a 2. This is my 6 sum. Oh, and that's a 7, that's a 6. This will be a 2, 3, and 1. And that is the central 5x5 taken care of. That is a very elegant opening to this puzzle by Philip. So now what? I'm going to take a look at these rows and these columns that have only 3 digits remaining and that also overlap with my remaining RSL clues. So this row still needs 5, 8, and 9. This row needs 5, 6, and 7. This column needs 5, 7, and 8. And this column needs 5, 6, and 9. So first of all, in these pairs, these 2 digits have to be the same. So this can't be a 6 because it can't match over here, and this can't be an 8. This can't be a 6 because it can't match this, and also this can't be an 8. And then the second thing to observe is that whatever this number is has to be the sum of 3 other digits, so it can't be a 5 because they all see each other. So those will both be 7s, which will be 1, 2, and 4. And by Sudoku, we know which order those go in. And so I can eliminate 7 from these 2 cells and from these 2 cells. That gives me a 5, 6 pair, which makes these 9s. I could have also worked out that those were 9s just based on the same logic as I used up above. I can't immediately tell how that 9 is composed here. I'm going to have to do a little bit more work to figure that out. So these will be 5, 6, 7, and 8. They can't be 5. These will be 6, 7, 8, and 9. They can't be 7. I'm going to look at these rows and columns now, starting with the topmost one and the rightmost one, because those are kind of full at this point. These digits will be 5, 7, and 8 in an unknown order. And these will be 5, 8, and 9 in an unknown order. So if we look over here, whatever this is has to be the sum of these 2. In other words, this cell has to be lower than the orange cell because it has to be part of a sum that combines to create that orange cell. The only way to do that with the digits we have available is like this. That makes this a 5. And we can carry on from there. These can no longer be 9s. This can't be a 5 anymore because if it was a 5, these 2 digits would have to be either 1 plus 4 or 2 plus 3. But because we already have both a 1 and a 2 in the column, both of those possibilities are off the table. That's now an 8, and this is going to be 3 and 5. So if we finish these two regions, this region needs a 6 and a 9, and this region needs a 7 and an 8. So how on earth are we going to make this 9? I can eliminate 9 from here too. So how are we going to make a total of 9 here? So the ways to make 9. So we can only use digits that are up to and including 6 because the maximal digit is the 6 that you get in the 1, 2, 6 combination. So if you have a total of 9 in 3 cells, you can start by pencil marking it with the digits 1 through 6. We can eliminate 1, 5, and 6 there because those appear in the column. We can eliminate 2 and 4 here because those appear in the row. So that will definitely be a 3, and that's a start. That means neither of these can be 3. This also can't be 1 or 4 because those appear in the column, and it can't be 5 because of the 5, 8 pair there. Okay, so now it's becoming a little bit more clear what the actual configuration of digits that composes this 9 is going to be. We don't even have a 1, so we can tell right away that it's the same composition as these. It's 2, 4, and 3 in that order. And at that point, we have classic Sudoku remaining. So in this column, we still need a 2, and it can only go here. That will be 7 or 8. This can't be an 8 because of the 5, 8 pair, and in general, these will be 1, 6, and 7. That's not a 7. Those can't be 5 because there's a 5 in the region. And that takes care of all of this, and I'm just doing a little bit of classic Sudoku to clean things up. Okay, let's finish this column. So we still need 6, 4, and 9, I believe. That can't be our 4 because of the 4 in the region, so the 4 goes right there. These will be 1, 2, and 6 in this order based on what's already appearing in the rows. So that's now going to be a 6. I have an 8 in this row. That makes this a 7. 8, 7, 8, 7. It's kind of bouncing around the grid there. The 6 here makes this a 9, a 6, and a 9. These cells need both a 3 and an 8. The 9 here gives me a 6 and a 9. These are going to be 4 and 7 in this order. These will be 3 and 6 in this order. That remaining digit in the column is a 5. This is going to be a 9 and a 1. And that is how you solve Philip Newman's Whirlpool. I hope you guys enjoyed that. I thought that was a very elegantly set puzzle. I enjoyed the symmetry there. I enjoyed in particular that opening where we get that 5 by 5 kind of square region of immediately fillable digits based on a little bit of arithmetic. That was kind of cool. So thank you, Philip. If you want to try that yourself, the link to solve it yourself in Sudoku Pad is in the description below this video. Enjoy!